Hi everyone, it's Jeff Hamilton. I thought I'd share a short video today of some of the best practices that I've learned over the years about how to make sure that I've got the power on or off at the machine with the use of a voltmeter, and to make sure that when I'm working on the equipment that the power's off so I can be just a little bit more comfortable with what I'm doing. When I work on electrical, I like to use a good snug fitting, cut resistant glove with a rubber liner on the face of it. Black nitrile gloves are good if they don't have holes in them. I like to use these over nitrile gloves. That way if these get wet, then my hands don't get a chemical exposure. The benefit of these, if you picture what's going on with the wire, any kind of live wire will have a plastic or vinyl insulation around it, and that's pretty much what a glove does for my hand. So for some reason, something went sideways, I made a mistake, I've got one added layer of protection when I'm working on that electrical system. Leather gloves work. The key is that they're dry. I've got the meter set for volts right now, and I'm going to have a couple of numbers on here that may or may not be significant. See, it says 0.00 something or whatever. We'll have a little bit of variance in between the meters that we have in the field, and some of them will read a dead zero, and some of them will have a little bit of a number behind a decimal point that moves around. That's perfectly normal. It's very normal to see a weird number in there when the meter's not connected to anything at all. That is a result of interference or static, if you want to call it that, from the battery that's in here. And it's the same if you're going to run a test on a bunch of wires that are running through a building and a bunch of conduits that end up in different places. At the end of that line, you're going to get a little bit of kind of static or interference at the end. The number that gets my attention is anything that's kind of close or above maybe 2 or 3 volts. If I see a number, it's 2, 3, 5 volts or something like that, or anywhere in between that and 120, I need to pay attention and double check. But I know if I see that number that I'm going to take a step back, take a deep breath, and start over until I get a number that makes sense. The first thing I want to talk about is the power cord. You're going to be used to seeing these and different stuff that we use and plenty of stuff around the house. They've got 2 flat prongs, and then there's a round prong right here. This is the ground wire. There's a green wire inside the cord that's attached to this end, and it goes inside the machine and shows up at the end of the cord. And then we have a green wire that comes off the cord, and it screws itself directly to the frame of the machine. That's called bonding. And what it does is it hard connects the prong here to the wall, and then it runs all through the machine, and that's what we call a grounded or a bonded machine. There's a white and a black wire inside the cord as well, and they come out at the end here. And in this case, I've got a couple of wire nuts and then another good jumper wire that goes to the on and off switch. So in other words, when I plug this cord into the wall, I've got potential available all the way at the end of the cord, all the way to the on and off switch there. And when we have the power switch off on the machine, the potential stops right there. It's not until I flip the power on that the potential goes elsewhere. And in our machine, it's a red wire. So if you looked at one of our machines and you saw a red wire, it's a pretty good chance that that's the power available to do work for us that's energized or has potential when we turn the power switch up or on. I'll make a mention about the voltmeter I've got in my hands here. This is pretty typical of the meters that you're going to see in our service. There's nothing special about this. This is a Home Depot item, I would guess. It's got the settings that we need. It does everything that we need it to do. It's probably 50 or 60 bucks. They're just great. The question comes up often for me, is it important whether I use the black or the red lead when I check stuff? And the only time that ever matters to us is if we're checking a DC motor, which is something you might find in a Titan. It would only give you a negative in front of the same number, though, either way. It just doesn't matter for all practical purposes if we use one or the other. But I've gotten into some habits, some really good habits, and I'm disciplined now to do the same thing when I check for voltage every time I do it. And one of my habits is to use the black lead as the first point of contact on the machine. And I'm going to connect to the least hazardous of the 2 choices that I have. So in other words, if I've got a white wire and a red wire, the red wire is the hot wire, so I'm going to use the black lead to touch the white wire first. That way I'm not in any danger of getting zapped. And then the only thing left for me to do is to touch the one that's live or has potential to do work or hurt me. And when I walk through this, you'll see me do the same thing. Another habit I'm in is whenever I've got the meter in my hands and I might be reaching for a tool, is I'm gonna turn the meter off and then back on to whatever setting I'm using. And what that does is it'll reset it. Most meters will have some sort of an auto shutdown timer in them. Some are shorter than others. And if I reach for the meter and I get all my stuff ready to go and I haven't reset it, often it'll be off and I'll have to start over. So this habit of resetting it does a couple things. One, it kind of resets the clock on the shutdown. And then secondly, if I've used a couple of different settings, if I've checked for continuity on something and then I go back to voltage, it just makes sure that I got my eyes on the meter to verify that it's on the setting that's actually the one that I want. And I don't get any bad info when I'm doing it. So what I'm gonna do is I'm gonna show you a couple places that are common for me to check, and then I'm gonna shut my mouth and pay attention to what I'm doing, and I'm gonna check for voltage after I plug the machine in here. Kind of a side note, when I do training or I'm with a group of people, I'm in a pretty dangerous position because I'm totally distracted from what I'm doing. If I'm showing somebody else how to use a meter in the field or in the shop, I really need to start paying attention. I'll often ask people to make sure that they know that they've got stop work authority if I'm doing stuff like this. Everybody's empowered to tell me, hey, wait a minute, I'm not quite sure about this. And it's happened to me before, and it's really helped me out. When I take a plug out of the wall and I'm working on a machine that's otherwise intermittently live during a training, I'll take the cord whenever I can and hang it over the machine in a place where everybody around me can see that it's actually not plugged into the wall. There's a little bit of kind of an emotional relief when I've got a crowd of people around me and I'm working around this stuff. And I've been on the other side of it too. And if I can see the cord, I feel that much better about the whole deal, and I'm able to focus just a little bit better on what's being delivered to me. Okay, so I've got energy on the machine right now. If you didn't have a voltmeter, well, we've kind of got one with the green light on most of our equipment. You can bump a prime switch to see if you got power or not. That's a good yes. I'll tell you what my best practice is from beginning to end. First of all, I want to set my meter to the setting that I want. In this case, it's V with a little squiggly line. That's alternating current, and that's what we're dealing with in a building. And then I want to get the meter out of my hands so it's not distracting. I'll put it somewhere like this where I can see the readout, but I don't have to hang on to it. Anywhere in here, sometimes I can hang them on the drain stopper chain. There's lots of different places. The AC44's got a cool little lever you can hook it on. And once I get it out of my hands, I'm a lot better off. There's a lot of places to check for power in a machine that you know that's on. And just to demonstrate what I'm doing, I've got the power switch back here, and that can be a little dicey. When I lean in there to do my work, it may be tight quarters, and I don't want to do anything that might cause one of these leads to bridge between anything that's live to the frame of the machine or bridge to the white wire, because I'll create a load and I'll blow the breaker, and I'm done doing that. So I'm going to give you a couple other places where you can check. First of all, I want to use the black lead as my best practice to check the one that can't hurt me. And in this case, it's our white or neutral wire. I don't want to assume that it's off. I still want to treat it as if it were live. But if it's wired incorrectly, then in fact it does not have any voltage on it. But right now I need to assume the worst. There's a white wire on our top control machines, and then there's a good place to check white wires in both the Perry pump box and in the timer box on our legacy machines, where all the common wires are kind of bonded together. And in the top control machine, I'm going to use the fuse for the chemical motors, which is a white wire. And there's two places I can just lay the meter lead down in there, and then I can see exactly what I'm doing when I'm doing it. And I'm just going to make a contact with it. I want to be pretty deliberate about it. Now that I've got contact with this live wire possibly, I want to pay attention to what I'm doing. So I'm going to look over here. The last thing I do then is I'm going to use the red lead to touch any white wire or any red wire. And I've got one right here, and my meter takes a second to kind of kick in, and then it says 124.4 volts. And that's great. It's validated what I thought I had. It makes sense. And that number, 124, it may be 108 in another building. It really just depends on the building, how far the receptacle is from the panel, and what the street is providing to the building. The numbers that are good with me are 110 to 100, almost 130. Anywhere in there, our machine will work just fine. So to demonstrate a couple of other places, I'm going to move the meter out of the way so that I don't get it in the way. And I'm going to keep my black lead on the white wire. And then the last thing I'm going to touch is this red wire on a prime switch. And I see I've got the same reading of 124.5. There are several places to look for red wire in here. Now, if I were in an account where I couldn't unplug the machine, I would want to get a helper. And I would ask for help from somebody on staff and go to the chef and say, hey, can I borrow somebody for a minute? And if I have, I think, identified the circuit breaker, maybe it's indicated on the machine, maybe it's written down on the breaker panel, and I think it's the breaker, then I'm going to ask someone else to go to the breaker with me. I'm going to show them which one. And if I can't hear them, I'm going to get them on a phone. And when I get back to the machine, I'm going to tell them to turn the power off when I call out. And what I want to do is I want to get a number that makes sense to me going on the meter, meaning I've got 125 volts on the meter right now. And then I'll holler out to have somebody unplug the machine to turn the breaker off or turn off the switch. Okay, turn it off. And then I'm going to watch that voltmeter reading go to 0. And I'm going to feel a whole lot better about stuff after I'm done with that. Now, there's a lot of places to check for voltage in the different machines that we have. The conveyor has different split systems, and if you've got an A4, A5 with a booster heater, it may have a control circuit that runs through that could theoretically be tied into another circuit. There's a lot to know with this. The purpose of this video is just to give you some tips on best practices, different places to check for voltage in the field, but there's no substitute for hands-on training with somebody who's done this before. None of us should be out there with a voltmeter checking for voltage on these machines until we received sufficient training from somebody who's done quite a bit of this. This is not a substitute for our best practices in our training. It's just designed to get everybody clued in on something that might help them out in the field. Thanks for joining me. Take care. Here's a close-up of the inside of a receptacle. If you were to look in there, you can see where on the receptacle that I got broken open, there's a spot here. It's kind of a clamp. And that's where the blade of the plug goes. There's one there, and there's one on the other side. And then you can see the one that's offset to a 90-degree angle right there. That would be for a flat blade. This receptacle was a 20-amp receptacle, meaning it can take that dedicated flat blade that we see on our U34B and ACB that has a bigger cord on it. When you reach into the receptacle, you'll see that you got a little bit of space underneath there you got to make up. And that's why I put the lead in the bottom and I kind of poke it up. That's what's happening inside. When I put the lead in, if I put it in there and then I tip it back down, that's where I'm making a contact with that clamp that's in there. It's not all the way up and down the slot.